In this example, there's no question about which is the more complicated side, right? We're going to, without question, start with the left-hand side. And so we've got the sine of x plus 1 divided by the cosine of x plus the cotangent of x. And, at this point, I have no idea how I'm going to get the tangent of x to appear from all of this. So I'm going to use my principle of saying, let's go ahead and make that cotangent into sines and cosines. So the one thing I do feel comfortable with here is that I definitely am going to need to get rid of this fraction within the fraction, right? The tangent of x is just the sine over the cosine. So I know there's not going to be this complicated fraction within a fraction. So even though I'm not sure exactly how I'm going to get to my end result, I do know that fraction's got to go. And I can do that if I just multiply by sine of x down here, which is fine as long as I multiply by sine of x in the top of the big fraction. All right, so on top, I'm not necessarily going to distribute yet because it's not clear that I need to. I may have to, but if you're not pretty sure that it's going to be required, you might as well just leave it. By the way, the other reason I'm kind of leaving it alone is since I know tangent is sine over cosine, I'm kind of thinking that this sine here is going to be a part of that, so I don't want to distribute that and lose it. All right, but down here, as I distribute, I end up with cosine x times the sine x, and then plus the sines cancel when we distribute through here, so just plus cosine x. Now, we know that we would like this 1 plus sine x to go away. And the only way I can do that is if I factor, and I can factor out a cosine of x. So we're going to go ahead and do that. So my sine of x plus 1's cancel. I'm left with sine of x over the cosine of x, which of course is exactly what we want. That's the tangent of x, which is our right-hand side.